Hello class, today we are going to talk about geometric constructions. Okay, now, what are geometric constructions? What this is way back in ancient times when they had all these ideas about math and geometry and they were trying to prove that it worked. They would know, okay, well it works with these numbers, does it work for everything? And so the idea they came up with is let's draw these pictures with no numbers at all. All right, so we needed to come up with a way to draw things without measuring. All right. So geometric constructions is a very precise way of drawing geometric figures, but all we're allowed to use is a compass for drawing circles, right? Or a straight edge for drawing lines. Now we said no measuring is allowed, so I am not actually going to use this ruler here. I'm going to get rid of that because that allows for measuring and we don't want to do that. So I'm just going to use a little straight line tool. Anything will work for a straight edge. You can just use the edge on a piece of paper, and that's a straight edge. All right. So the first thing we are going to do is we are going to copy a line segment. Right? Drawing a line segment, not a big deal. We're going to copy a line segment. So I'm going to draw another line segment that is the exact same length as AB. It is congruent to AB. So I need to, step one, draw a ray there. So give me my line tool, and let's just draw a line segment. It has to be longer than AB. So AB, notice there's no symbol there. That means it's longer than the length of AB. So there it is. That's definitely longer than AB, right? Okay, so step two, label the end point of the ray as point C. Okay, so I need to have point and C. There we go. Point C. Place the center of the compass on A. So the center of the compass, that's right here. That's the stabby end of the compass. Or if you have something that on a software that makes circles, that's the center of the circle. So there it is. Let's move that away so I can read this. Okay, so the center, the stabby end of my compass, is on point A, right there. Set the radius to the length of AB. So I'm going to take this, and I want the pencil end over here to AB. If I'm in a software that's drawing circles, I want the radius of the circle right here. So when I draw a circle, it'll draw a circle right there on point B. All right? Without changing the radius, move the compass to C. So I'm going to take the center of my compass, that stabby end, and I'm going to put it on point C. Like that. I did not change the radius, so it's still the same width it was a minute ago. Draw a line across the ray. Not a line, an arc. An arc is a piece of a circle. So draw an arc across the ray like that. Label the intersection as D. So let me move that out of the way. This intersection right here, I will label as D. And I now have segment CD is the same length as segment AB. How do I know it's the same length? Well, because I didn't change my radius, right? And so if it reaches there and it's the same radius here, that means it must be the same length. I didn't do any measuring at all, and yet it's still the same length. There's a couple of things we can do with this that are kind of nice. I could, if I wanted, I could make a segment that is twice the length of AB. Right? I could just start right here. Bring this down. If I draw one mark, okay, that's AB. If I come right here and draw another mark, well, that would be 2AB. So here I would have segment EF that has the length twice the length of AB. Other things we can do with this. We can actually use this to draw equilateral triangles. Okay, so this is one that y'all will be doing. And we're going to do this one in Delta Math. So equilateral triangles, that way I can show you how it works here. So I'm going to use Delta Math to construct an equilateral triangle where all three sides are the same length as segment VW. Okay. So first I'm going to get a compass. All right. I'm going to center it on V, and I'm going to take the other dot, this is my radius, and put it on W. Okay, and you can see there's a very light dotted circle there. I put my pencil on it, you can see a little bit better. Okay, now on this, instead of drawing that ray to begin with, I'm just going to draw these three things. So I'm going to start at V, and I'm going to draw a line. What did you say? So if I could draw, hold on, I need to draw my compass again. Okay, so I'm going to go ahead and draw an arc like this. Okay, because there's a circle, every single point on this arc is the same distance from V that W is from V, right? So I could draw a segment from V to here, and well, that's going to give me an isosceles triangle because it's the same length as it is from V to W, but I need to know where to put this so that from this point to W is the same length, right? So is that right? Is it not right? I don't know. Let's give it out. So what we're going to do, we're going to take this compass, so we need the same length here. Okay, so we've got this compass, and now I'm just going to move the center from V to W. Notice my arc is still hitting on V, right? So my radius is the same, and I'm going to just draw the intersection here. So now this point right here where they intersect, well, it has the length of VW away from W, right? Same length away from W. And when I move it over here, same radius, it's the same length from V as it is from W because the radius of the circle is the same. And so now I can draw my segments from V to this intersection, and from that intersection down to W, and I have an equilateral triangle. So all three sides are the same length. Right? And I come over here, submit it. Are you sure? Yes. And I get a nice little check mark because I did it right. Yay. All right? So that's how you can do that. I'm going to do one more construction really quick, and that's this next one here. Construct a perpendicular bisector. So if you remember, to bisect something means to cut it perfectly in half. It's going to go through the midpoint. So what I'm going to do is I'm going to take segment BC here, and I'm going to divide it into two segments that are the same length. It's going to be the midpoint. All right, so first I'm going to start with my compass. Center it on C or B, either way, center it on one endpoint, and we want the radius of this to be more than halfway to the other endpoint. All right, so I could set it here, that's definitely more than halfway. I wouldn't want to set it here, that's definitely too short, not at least halfway. Here, maybe I'm good, maybe I'm not. Let's play it safe, let's go somewhere out here. I could even come way out here. This is definitely more than halfway to B, right? It's all the way to B. But I don't want to be quite that big. So I'm just going to set it somewhere up here. Okay, so I've got my circle here. Here's my compass. Definitely more than halfway to B, right? Because it's almost there. And I'm going to make a nice big arc with my pencil. Nice big arc like that. Next step, I'm going to take point C. I'm going to take the center of my circle, and I'm going to move it to the other endpoint. I am not changing the radius, so I'm just move this to the other endpoint. And now I've got the circle over here. What I want to do is I just want to make a little arc right there and a little arc right here, so it intersects this first arc. If you want, you are more than welcome to draw it all the way through. That's fine, but it's not necessary. All you really need is to put this little bit of arc there and a little bit of arc there. All right? Now what we're going to do is we're going to connect those points. So I will take a segment and connect those points, just like that. Now you're asking, well, how do I know that this is the center? Well, I'm going to pull my compass up again. I'm going to center it on that midpoint, take it out to C, and notice this is a circle, right? Every point on the circle is the same distance from the center, and so we see that the circle goes through point C, and the circle also goes through point B. So C and B are the exact same distance from the center of my circle, which means that these are congruent. I could also look at it like this. I could put the center on point C, and the circle goes through the midpoint. I could put the center on point B, and the circle goes through the midpoint. So this point right here is the same distance from both endpoints, so I can see that, yep, that is the midpoint. All right, so I'm going to submit this, make sure I did it right. No, it wants a line, not a segment. So let's, oops, oh well. And I meant to hit cancel so I could change that segment to a line, and I didn't. Whatever. Let's do it again. Let's make it right. So, yeah. So compass, more than halfway. draw an arc, move it to the other endpoint, intersects there and there, and this time instead of a segment, we want to draw a line like that. All right, and submit it. Yes, there we go. Now it's happy because I used a line and not a segment. All right, all right. So those are constructions. We will be using these to prove theorems in the future, because if it works with no numbers, then it'll work with any number. Doesn't matter what number you put in. All right. Only allowed to use something to draw circles, and only allowed to use a straight edge. That's it. Straight lines and circles is all you're allowed to use, and there is no measuring involved. Notice I did not use a ruler for any of this. All right? And I hope you found that useful. I'll see you in the next video.